Hello everyone. Today we discuss about 8051 microcontroller instructions. Okay, there are so many instructions that are available in 8051, like data transfer type, arithmetic type, logical type, branch and control, and machine control type instruction. Okay, so first of all we discuss about basic data transfer or known as move instruction. So first instruction is move. These are typical type. These are destination register here, and here we mention source register. So now these copy the byte from the source location to the destination location. Okay, and there are various possible combination for this type of instruction. Say for example, move accumulator, and here we mention the hash symbol, and here we mention the data. That means, for example, if we write this instruction, that means this 25 hexadecimal data, this 25 hexadecimal data is transferred to the accumulator. Okay, next type is move accumulator R of n. Why n? Because R0 to R7 is used. So for example, if we use move a comma R4, that is the content of the register of R4 is transferred to the accumulator. Next type is move accumulator direct. So what is a direct? Direct means move. If we write this move 30 hex, no hash is present, that means data in 30 hex memory location. Okay, that means in a RAM address, these are 30s because we no used here hash. So this is basically a memory address, RAM address. The content of the RAM address, that means the data in the RAM address, are transferred to the accumulator. So this is very important to memorize this notation. Next, move a comma @RI. Okay, this I equals to 0 or 1. Basically this I equals to basically 0 or 1, any one. Okay, so now if we use move a comma @R0, that means the data pointed to by R0. Okay, so these are basically data pointed as used as a data pointer. Okay, so now these all different 5 types are used when register A is destination. That means accumulator is a destination. So these are 5 different types of move instruction, first of all. And now when the second type is when register A is source register. Okay, now discuss about that. And first example is move Rn comma A. That means the accumulator content transferred to the R0 to R7, anyone. Next, move direct. Direct means the RAM address. So direct address means accumulator data transferred to the direct addressing. Next, move. Here we use the pointer. It's just the reverse operation of this. Okay, this is point out the data pointed to by R1. Okay, this is transferred to the accumulator, and the accumulator is transferred to the data pointed by. That means this RI basically in the RI is basically the content of the RAM address location. So as in a C, when you use the pointer of C, these are basically the same concept. So from here the pointer concept is coming out. Now we discuss about destination is a direct address. Okay, now we discuss about that. Now when destination is a direct address, we use another different types of instruction: move direct address hash data. So you store the data in direct address. Next, move direct address but pointed by RI register. Okay, then move direct from accumulator. Next one is move direct from RN, that means register bank. Next, move direct to direct, that means from one program location to another program location. This direct address is basically the that is basically the program location. Okay, so that means the program address, that is the memory address, or it is also known as the ROM address. Okay, and the next one, that is we discuss about this thing. Register is a source, then destination is a direct address. Now we coming out our fourth point, when Rn is destination. When Rn is destination, okay. Now some instructions are available. Move Rn comma immediate. So here immediate address are used, and transfer of immediate immediate value is used, sorry, not address. So here hash symbol is present, it's directly moved to the Rn. Next, it is very easy, accommodator to Rn. And next one is move Rn comma direct address. So again 16-bit direct address is used, the content of the 16-bit address is directly transferred to the Rn. And the fifth one is the destination is an indirect address held by R0 and R1, okay, the indirect R0 and R1, okay. So now we see that what type of instructions are available for this type of instruction. So destination is an indirect address held by R0 and R1. So first instruction is move @RI. This is hash data. That means the value of data is transferred to the pointer which is pointed by the RI register. Next, move @RI. The data from the accumulator is transferred to the pointer. Next, move @RI. Direct address value stored in the pointer which is pointed by the RI register also. So this is the different types of move destination and source registers. Now the second type is, so there are basically lots of instructions are available for the first move destination to source. Now our next instruction type is move destination bit source bit, okay. So now for this example, move bit data. So basically this instruction copies the source bit to the destination bit. And for example, move 1.1 C. What is the meaning? That means copy the carry bit in port 1.1. Say for another example, move this. That means the status of the port 1.1 is transferred to the carry flag also. So these are basically move bit operation. Now next is move DPTR data pointer register hash 16-bit value. 16-bit val, that means value. So what is the function? This instruction loads the 16-bit data pointer register with 16-bit immediate value. That means if we use this instruction move DPTR, say for hash 81FF, say for example, then this number is loaded to the DPTR, okay. Okay, right? Yes. Now we discuss about next instruction, move C A comma @A plus DPTR. So this is very important, DPTR. So now this instruction moves the byte data located in a program code, that means ROM, into register, okay. And basically what is thing, the DPTR is basically located by an address which is addition with accumulator value, and this joined these two value, accumulated these two value, it's create a pointer, and this memory location content is transferred to the into the register, okay, register A, okay. So this is the working mode of this instruction. So basically this instruction moves a byte of data located in a program code ROM into register A, and this ROM location selecting by DPTR plus accumulator value, current accumulator value. So it's basically used for array of, when we use array of code or array of data are used, then therefore if accumulator content equal to 00, then therefore DPTR starting from the 002 and incremental value depending on the array size. Next we talk about move A comma @. So it's basically the same program counter. So this is basically moves a byte of data located in the program code area to accumulator. Okay, the address of the desired byte of data is formed by adding program counter register to the original value of the accumulator, okay, and transferred to the accumulator. Okay, so this is the beauty of this instruction. Now next we talk about our another instruction, move x destination byte source byte. Okay, so now if we use move x a comma @dptr, so now what is the function? This moves into the accumulator a byte from external memory whose address is pointed out by dptr. We just talk about the what is the internal memory and the external memory in 8051, because we can also connect the external memory to increase the memory allocation in the 8051 microcontroller. Okay, so next is just a reverse operation, move x @dptr comma accumulator. So it's just a reverse operation. This moves the content of accumulator to the external memory location whose address is held by dptr. Okay, next one is move x @ri. So that means this this pointer location data is, sorry, here a is mentioned, move x a comma @ai. So therefore the 8-bit address of external memory is held by r0 to r1, and this moves the accumulator a byte from external memory whose 8-bit address is pointed by r0 and r1 respectively. And just for the reverse operation we use another instruction. Is this instruction is just the opposite operation of this, because this is a pointed memory location where the data is transferred from this pointer memory location to a accumulator, and it is accumulated to the memory address whose 8-bit address is pointed by r0 and r1 respectively. Next instruction is very important. This is multiplication of a b. That means the accumulator content and b content both are multiplied, and after this the here multiplies of unsigned byte in accumulator by unsigned byte in a register b, and the result is placed in accumulator and b, where a has the lower byte and b has the higher byte. Okay, so this is a move related instruction of and different types of also arithmetic and indirect direct addressing modes are discussing here. Now we next one important instruction for delay operation and no operation also perform. This is a no operation perform execution, and execution continues with the next instruction. It's sometimes used for the timing delays to waste the clock cycles. So okay, so no operation, this NOP means no operation. So that's why this is a very important for delay generation programming. So now next we discuss about some arithmetic instructions. Okay, so first of all we discussion about add instruction, add a comma source byte. Okay, this add a comma source byte is basically very important. Okay, now see that the very important point about. Okay, next is, for example, for this add instruction, add a source byte. For example, move a comma something 12 is a data, and then add a with hash 45. So what is the result? Result is basically 57 in the accumulator, because after addition the result is stored in the accumulator. Okay, so this is a working function of this add instruction, first arithmetic type instruction. Next we see that another instruction, add a with the source byte. That means add accumulator plus source byte plus carry bit and store the result in the accumulator. Okay, now next arithmetic instruction is basically the decrement byte. This decrement byte, so basically this is use here decrement a. That means if the content of accumulator say any number, then decrement a means it's just decrement -1. it's also performed in another register bank, and also perform of the decrement direct. For the example, for the decimal byte stored in a RAM location, this is also decrement by this addressing mode, and also by using pointer decrement @RI also used, where decrement byte pointed to by R0. Okay, so this is a basically decrement operation. Next is increment. So decrement and increment are the same features. It's decrement the number but it increment the numbers. Okay, this is INC, and one instruction is available, another instructions increment DPTR. That means increment the data pointer register value. Okay, and the next instruction is, so these are the basically the multiplication, also the arithmetic operation in 8085 registers, 8051 microcontrollers. And next one is divide operation in 8051. There another advantage, there is another instruction is available which is known as div. Okay, so div of AB, that means this instruction divide a byte accumulator by the byte in register B. Okay, it is assumed that both register A and B are contained an unsigned byte, and after division, student please note down, after division quotient will be in the register A and the remainder is stored in the register B. Okay, please note that, it's a very important. So now these are the basically the arithmetic instruction, and another instruction is DA. It's the same as a 8085 DAA, decimal adjust after addition of accumulator. For the BCD, this instruction used after addition of BCD numbers to convert the result back to the BCD again. So these are decimal adjust after addition. If we addition of decimal numbers and show the number in that and show the result in the decimal form, then we used the decimal adjust. Okay, the decimal adjust is basically follow the two rules. So the instruction format is basically DAA. Okay, DAA, decimal adjust of accumulator, that is the two algorithm are followed. It adds 6 to the lower 4 bits of accumulator if it's greater than 9, or if auxiliary carry flag equal to 1. So when accumulator when the lower 4 bit is greater than 1 or auxiliary carry bit equal to 1 auxiliary carry, then it adds with that bit 4 bits. And number 2, it also adds 6 to the upper bits of accumulator if the upper bits also greater than 9. Okay, and also carry flag equal to 1. Sorry, carry flag equal to 1. Then this instruction will be performed to correction the BCD number to convert the result back again to the BCD number itself. Okay, so now we discuss about the another instruction, logical instruction also, and other instruction also available. The many logical instructions, say for ANL. ANL is basically logic and operation destination here source. Okay, so ANL means logical and operation performed. Say for example ANL between register A and this data 09. So basically this data and the accumulator is itself AND operation, and the result after the AND operation, the result is stored in the accumulator. And next ANL C, source bit. This is a bit by bit logical AND operation are performed. Say for example ANL carry flag and any other port. Say for example if we perform this instruction ANL P3.1, that means this port bit P3.1 and carry bit are logical AND operation to each other. Okay, next instruction is, these are the two logical, and next instruction is complement accumulator. This is also complement accumulator. The accumulator byte is complement. Next CPL, complement bit. Individual bit can be complemented by this instruction. Okay, next one is our next instruction for this type, that is OR operation performed. That is as same as ANL, the OR operation is also performed, that is ORL, destination to source also be performed. These are same for ANL, if OR operation performed between 0 and 9, then OR operation performed between these two value, and after this stored in the accumulator. So it's also same for the ORL C comma source bit. Okay, so it is also for the bit by bit OR operation, logical operation performed in the 8051 microcontroller. And the another instruction for the clear, to clear the register, the another instruction is used for clear A, that is clear the accumulator, then clear bit, individual bit can be cleared by this instruction. Okay, so the next instruction, our next instruction is rotate instruction. Okay, rotate. Say for example, we mention RLA. That means, what is the meaning? This means rotate left accumulator bit. Okay, and the bits rotate out of accumulator and rotate back into accumulator at the opposite end. That means if we consider these accumulator bit, these are D7 bit and these are D0 bit, then after rotate accumulator left, this D7 bit goes here, and every bit in this register A will be left side shifting by 1 bit. Okay, next Rlca. Rlca means this is quite different with respect to RLA, because here rotate accumulator left, this MSB bit goes to carry bit, and then the carry bit goes to the D0 bit, and remaining bit shifted left side by 1 bit. Okay, so this D7 bit is first shifted to carry bit transferred to the D0 bit, and other remaining bit shifted, yes, in the left side. So for same is just opposite direction, rotate accumulator right, not through carry. Okay, so it's basically the same, because, and the only difference is it rotates in the right direction. And also there are another instruction RRCA. RRC is rotate accumulator right through carry bit. Okay, so this is a rotate related instruction. And another instruction is also known as we mentioned for the clear instruction, there is another instruction is for set B bit. Okay, that means if we write set B port 1.1.3, that means this bit would be set by this instruction. Okay, so there is the importance of this set B instruction. And there are another arithmetic instruction are also available for subtraction, that means sub BB A comma source byte. Okay, so this instruction is basically subtract the source byte and carry flag from the accumulator and puts the result into the accumulator. Okay, it should be remembered. This is the importance of sub BB instruction. And next, another time instructions are swap accumulator. So these are swap instruction, interchange the low and level. That means in the accumulator, the lower nibble is from D0 to D3 and higher nibble is from D4 to D7. So these are interchange between them. Okay, so this is the swap instruction can be executed by this 8051 instruction. So there are also many different types of instructions are available. And in the next video, we discuss about the remaining instruction related to the jump and control and machine control, and also the compare and then jump instruction are discussed in the next video. That's all for today. Thank you.